Hello everyone, I'm Luís Espírito Santo, and as one of the co-organizers of this remarkable volunteer group, I'm pleased to welcome you to the closing session of Deep Learning Sessions Portugal 2023. It's been an incredible year filled with exciting advancements, inspiring collaborations, and a shared passion for artificial intelligence. I am thrilled to share with you what we have accomplished this year. But before delving into the details of our initiatives, let me take a moment to acknowledge this extraordinary team that made it all possible. This year, we started with 9 members, and it was thanks to their dedication, expertise, and tireless efforts that I can present these achievements to you today. I would like to provide a special shout out to Marta Guimarães, Manuel Madeira, André Macedo, and Augusto Pérez, who put in extra effort to make all this happen. For those of you who are not familiar with us yet, Deep Learning Sessions Portugal is a group of volunteers focused on organizing events around deep learning and artificial intelligence. We are a community of AI enthusiasts that started in 2019, and we have a mission to share knowledge about the advances in AI both in Portugal and abroad, promote collaborations between diverse kinds of people from different backgrounds, areas, and sectors across academia and industry, while also aiming to improve AI literacy among the general public in Portugal. This year has been quite remarkable. We have grown our Meetup subscribers to 2,250, and our LinkedIn followers have reached 1,500. However, we still need to do some work on Twitter since we currently have only 300 followers, but rest assured we are working on that. Moving on to our content. This year we received over 3,000 visualizations on YouTube and had more than 100 streams of our podcast. We also sent out more than 600 of our monthly newsletter about deep learning in Portugal. Now, let's talk a bit about our initiatives. We have 4 different categories: social events, do-it-yourself, creating new content for you, and even launching now new tools and resources. But before we dive into those, let's briefly mention some initiatives from last year that we didn't include this year, but that we believe might be of your interest. So last year, we had, for example, a role-play reading group, a different way of conducting reading groups that made them more interactive and exciting. Everyone participating takes a role and has a different perspective on the paper that we're studying. We also had conference watching sessions where we watched new research presentations together. Last year we had Neuraspace, but unfortunately this year we couldn't continue with those due to the conference, to some conference limitations. However, if you find these initiatives interesting, these events, please let us know, and we will consider bringing them back or exploring similar activities in the future. We also paused our blog posts this year to focus on other initiatives, but if you believe our blog posts were valuable, please provide us with your feedback and we'll consider not just reviving them, but also creating new content. Now, let's move on to the initiatives we continued from last year, and one of them is our opening event, a roundtable discussing the developments and predictions in AI, which has become a tradition now. We started the year with another insightful roundtable discussing the trends in 2022 and the predictions for this year, 2023. Our videos have been a great way to ensure decentralization of our content. That's why we kept them. We make sure to make every meetup available on our YouTube channel for everyone to access and benefit from the knowledge shared. So please check out our YouTube channel where you'll find a wealth of content to enjoy. Our monthly newsletter on deep learning in Portugal summarizes the important happenings in the field each month, covering business, research, useful tools, opportunities, and even events. we recognized that there was a need for a centralized point of information about deep learning research in Portugal. So we decided to launch this initiative to ensure researchers and enthusiasts have easy access to the latest developments and opportunities in the field. If you have something to share, please let us know. We collect all these valuable insights and want to share them with everyone. Lastly, we also continued our research meetups, providing a stage for national and important research in Portugal. This has always been the primary goal of our group since the beginning, and we are proud to have continued this initiative. This year we focused also on launching and especially new initiatives to diversify our offerings. The first one was pet projects. We created a forum to collect projects that you might be working on the side and that you'd like to share with the community. It's a way for us to showcase these interesting projects and possibly connect you with project partners. We also launched our new website, which serves as a centralized hub for all our information. You can find links to our LinkedIn, Twitter, YouTube, Meetup, and other platforms, making it easier for you to access all our content and initiatives. To further promote physical interaction, we organized more physical events this year as well. In addition to paper-focused meetups that this year became more physical events, we also introduced the PubHD session, an informal gathering in a partnership with PubHD Lisbon that happens at a pub where two PhD researchers discuss their research topic in Portuguese, allowing the entire community to engage in simplified terms. Recognizing also the need for different content consumption options, we launched finally our podcast. Now you can enjoy our content in audio format, whether you're working out, cooking, or simply prefer listening over watching. CodeQuest was another exciting initiative we introduced. It combines learning from experts with individual exploration. It's a balance between these. We started with a challenging problem, and we provide experts that guide you through the initial phase, and then we encourage participants to continue solving it independently. Although we couldn't complete the final part of the initiative this year, which was supposed to be a small hackathon, but we have secured partnerships to ensure we can make it happen next year. To facilitate community interaction and discussions, we launched our Discord server. It provides various channels dedicated to different topics, including also diversity and inclusion, and a dedicated channel for Portuguese-speaking individuals. We invite you to join and bring your friends and make that your space. Finally, we have this closing session, which we usually couldn't organize. Thanks to our sponsors, this year we were able to make it happen, and it's even more special because it's our first event outside of Lisbon. We're excited to decentralize and extend our reach to other cities in Portugal. This event focuses on AI4Science and includes a roundtable discussion. We hope you find it engaging and insightful. Finally, I want to express my gratitude to all the speakers that presented this year, all the partners, all the sponsors, and especially all the participants that participated in our initiatives, as well as to you for being here today. We encourage everyone to get in touch with us if you have anything to contribute, feedback to provide, or new ideas to share. Let us know if there's an initiative from the past that you would like us to revive, a partnership you want to start, or a new initiative you would like us to work on. Your input is extremely valuable to us. And now, please sit back, relax, and enjoy this session. Thank you very much.
Thank you so much. So as Luis mentioned in this video, this is our first time ever outside having a physical event outside Lisbon, so this is really exciting for us. And if you do have other ideas, I don't know, maybe challenges, workshops or whatnot, something, projects, it doesn't matter, something that you want to do with us, some collaboration, feel free to send us a message. The best way to find us is through LinkedIn. The only thing you need to do is just you search Deep Learning Sessions Portugal, and from there you can find everything else. So now I think it's the moment, and I think we can start with our AI4Science talk. Today we have here with us, oh by the way, I'm Marta. And we have here with us Cláudia Soares, professor at FCT, Nova University of Lisbon, and a consultant at Neuraspace. Then we have Arrais, researcher at Universidade de Coimbra, in deep learning applied to computational biology, bioinformatics, and drug discovery. Hugo Penedones, co-founder and CTO at Inductiva Research Labs, and then Inês de Castro Dutra, professor at Universidade de Porto, and sorry, it's wrong over there, apologies for that, and principal investigator of the AI4L group. So that's it, I think we can start. Let me just grab my questions. Okay, so I think we can start with the general topic of AI applications in scientific research. And as you know, in the recent years, AI has emerged as a powerful tool for accelerating scientific research in many different disciplines and different areas such as biology, physics, healthcare, and space, the areas that we have here today. And we have seen remarkable advances in using AI to analyze large data sets and, for example, to simulate complex systems. So I invite each one of you to talk a little bit about specific applications of AI in your area of expertise. For example, how has AI been used to improve scientific research in that specific field? Which algorithms or techniques are commonly used in those domains? So, Cláudia, I think we can start with you.
Okay. So, first, I will have a small dissent with the whole organization. I think that I don't really identify as an AI researcher. I identify as a machine learning researcher. So, this is, I think this is something that for me, talking about artificial intelligence, and for those of all of us that know about the old days of McCarthy and all those people. So I don't do that, I do machine learning, and I think this has been the major area of improvement that allowed for all of those nice eye candy and all the nice things that we've been seeing lately. So a bit of a dissent with the title of the roundtable, also because the expression artificial intelligence can be a bit deceiving, because it brings us back to the Terminator movies and things that are really not real, right, and that are not aligned with whatever we do. And so I consider myself a researcher in machine learning. I've applied my algorithmic and model knowledge from underwater robots and now to space and healthcare also. So, and I see machine learning basically as another instrument that we have. So first we had measurements to improve our instruments, and now we are together building a lot of nicer instruments that are allow us to be more precise and kind of create knowledge that is more clear. And in a sense, I think everyone that are sitting here, we are looking at, in a sense, how to put some mechanism in a data fitting problem, right? So, and this is what excites me in this field, especially in the physical sciences and the physical world. And of course, even when we look at communities of people, we are seeing a complex system that behaves very much like a physical system, right? And that's why when you start looking at crowd behavior and complex systems, you tend to see a lot of this emergent behavior that you see in physics. And so I don't know if I've answered your question.
Maybe you could give us some specific example on for example, why it makes sense to apply AI for space, and maybe some example.
So one area where this machine learning, the machine learning power can express itself is because we are explaining, we are trying to describe mathematically uncertain data. Okay, in that sense, we can have the mechanism like a grounding of what is going on. For example, orbits, satellites go in orbits. Orbits are we assume, quite regular movements. But then there's all the rest, right? All the stochasticity that we see around, solar winds, changes in the gravitational forces that actually interfere with the orbits. So all of that we cannot predict because our models are not good enough and because there is inherent stochasticity in the process. And so this other layer, let's say, of uncertainty is where the power of machine learning can come. And to do that, if we actually own the distribution of everything that is unknown, then we have a very powerful key to predict what will happen next. Because this will be the final goal, right? Predicting the future.
Okay, good. I like that you keep saying machine learning. I need to be careful. Let's change. What about you? Can you give us some examples?
Good afternoon. So I'm very pleased to be here. Normally when I participate on these events, I learn more than I think that I'm able to share. So I'm very eager to be here and to be able to discuss with all of you the work that he and in my lab that we are doing, and of course to try also to see and to understand and to learn what other words are being applied to machine learning or artificial intelligence are being applied. So I think that now after Cláudia I also have to make some declaration of interests or something like that. Well, I must say that I'm not a researcher in AI also, but mainly, and I'm saying that mainly because what I do, it is I work with state-of-the-art algorithms and methods in deep learning and AI, that's for sure, but I don't think that my focus is not so much in contributing to push the frontier of the state-of-the-art, but more to apply it to problems that for some reason are of interest to me. So I think that it's important. So I would say that I am a researcher maybe in deep learning for biology. Maybe that will fit well in the work that I and my colleagues are doing in the lab. Okay. So the second part, and I think that's the question that it is, well, we use a lot deep learning, and we use a lot of the current methods for that currently are known as the state of the art. And especially what we are trying to do in the lab, it is to use these advanced generative models. And well, in simple terms, what we are doing, it is to do something, well, it is quite easy now to explain it. It was not so easy 10 or at least 5 years ago when we started. It is a ChatGPT, but for generating molecules that could be used as drug candidates. So actually what we are doing, it is generating the equivalent of a language model, but instead of using it to generate texts that could be read for us. Actually, it's also generating text, but it is generating text in a language that represents molecules. And then we are able to train and to make sure that the molecules that are generated are for a specific target and for a specific for binding for a specific protein and for a specific disease. So I think that's an easy way to put really how all of these advances that are occurring with the language models and the transformers and all of the state-of-the-art deep learning can be applied to my field of research. It is exactly this one and the model that we are very motivated to building in my lab. Not sure?
Yeah, perfect, perfect.
Excellent. So my background is also on computer science and machine learning, research and engineering. I am actually quite a generalist. I worked in different things from computer vision, time series, to an application in actually computational biology and molecular biology. When I was at DeepMind, I was one of the initial members of the AlphaFold project, in which we was really dealing with the problem of predicting the structure of proteins from their amino acid sequence. But here, let's focus more on physics, right? Because now I'm a co-founder at Inductiva, which is a research-driven startup that we launched 2.5 years ago. And here we are kind of trying to merge the world of simulation and machine learning. So, and it's a bit broad spectrum. We cover physics, it can also involve biology or chemistry, but let's focus on physics. In physics, if you think of the tradition for centuries, what scientists try to do is extract patterns, or what you can call physical laws, from observations of data, right? So this, if you think about it, is very similar. It's literally what statistical machine learning tries to achieve. This is the same thing. It's looking at observational data and find a compact model that explains this and generalize to unseen data. So it's not, to some extent, it's really not surprising that machine learning is disrupting science because it's kind of automating science. So in physics, you can think of, okay, take it with a grain of salt because I'm not a physicist, but the basic fundamental laws are pretty well understood, right? But you cannot compute everything from first principles, right? Like you might know Schrödinger's equation for quantum mechanics, but you cannot compute from first principles how large-scale matter behaves from quantum mechanics, even at the level of small molecules, right? Once you start having a protein or even much smaller molecules, you can no longer compute anything from first principles. So then you go to a level in which you start needing some heuristics just to make things computationally tractable. So then again, it's evident how machine learning can help, right? Because this is away from the human intuition, right? Maybe humans are able to have an intuition on if I throw a ball, where does it fall? But you cannot ask a human to have an intuition on how a protein falls looking at an amino acid sequence, right? So if we have these algorithms, these machine learning algorithms that have a principal manner to learn from data, they can learn from observational data in science, like experiments about the shape of proteins or other things, and do it much better than us, right? So it's not surprising that machine learning is contributing to all of this.
Great. Thanks. Inês, what about you?
Thank you. Yeah, I have some comments to make, and then I'll answer your question. Some of you said that you are not doing AI, but machine learning is a subset of AI. So in my opinion, you are doing AI as well. So that's just a comment. So regarding my research and what we can do to help solving problems, right? Because this is the main. I mean, this is my main goal actually. Solve problems, like Joel was saying as well. I've been working with several different things, not exactly in the health area, although I am in a group of AI for health. I've been working with sensors, basically smoke sensors, and autonomous driving, and molding machines, and all these things in some of the projects that I've been involved with. And the kinds of models that we apply to solve problems in this area, the problems that we try to solve are basically supervised and unsupervised. Like if I have supervised labels in my data, we can do things like classification or regression or forecasting. But we also do some exploratory analysis, because exploratory analysis is very important to understand the data and to see what we can do with that, right? So using exploratory analysis also is useful for building models that are interpretable and that are explainable. And I had explained to Liege that my area was not exactly deep learning, because I don't do anything with deep learning anyway. So my area is more related with AI, symbolic AI, because I think that symbolic AI deep learning is very good for some tasks, right? For perception and for recognizing pattern recognition, all these things. But there are some things that are more important in AI today for me, that is planning, reasoning, and decision making. Mm-hmm. And for planning, reasoning, and decision making, I don't think that deep learning models are sufficient. So the models I work with are models based on probabilities and based on rules. Yeah, I think this is it, and I'm more interested in solving these three problems that are planning, reasoning, and decision making, and using interpretable and explainable models. This is what my research is.
Looking at probably some of the work that you have already done in the area of healthcare, can you give us just one example for us?
In the healthcare, we managed to extract some rules from mammograms, where we could explain some mammograms that had BI-RADS level 5, that's malignant cases. Basing our reasoning, also all our reasoning on the features that the medical doctors extract from the image. So, and this was published, and this is something that, I think that was important at the time. And we keep going. I work with images, but not extracting features from the images, only with annotations, because the radiologists, they have a special vocabulary to extract annotations from the image. And these annotations were extracted, and we work with this data that is all categorical, not numerical data. Using this data, we could generate rules that could say, if this thing happens, and that thing happens, and that other thing happens, then the case is malignant. So this is one of the things that I can say that is, I think we were very successful.
Great, very good. So I think now all of us have a bit more notion of some possible applications. Claudia, you actually started a bit talking about this, and Hugo, you as also. I'll launch the question, and I think you can grab this one. So given the rapid advances in ML, not AI, and its increasing integration into scientific research in all of these different domains and areas, there is a growing notion that, in fact, ML may emerge as a new scientific paradigm. Given the ability to discover different patterns, generate hypotheses, and streamline data-driven decision-making, do you believe that ML has the transformative potential to redefine how we approach scientific research and maybe to some extent reshape our understanding of the natural world?
Okay, I can start.
Okay, you can start. Yeah.
Yeah, I believe so, and it's happening, right? It's an emerging trend. Like the history of AI started more on imitating the human capacities of perception and maybe reasoning and related to vision, speech, language, and so on. But we see this now trend of using some of the same techniques that were developed in these communities to tackle scientific problems. And if you think about it, in particular machine learning and neural networks, what they are good at is learning latent representations, compact representations that are meaningful and that abstract away the high dimensionality of the input, and then you can reason in a much lower latent space. And in some problems in science, this happens a lot, right? Like from mathematics, in which if you need to prove a theorem and you do it at the level of step-by-step, logic step, a very detailed thing, the path from a theorem to the axioms will be huge. So you cannot try to automate this by doing a brute search in this space, right? So machine learning is helping here to make systems that reason more like humans. They reason at a level of abstraction in that latent space that can be much smaller. We have seen examples of contributions to computer science like this, finding smaller or shorter algorithms to multiply matrices, to do sorting algorithms with fewer operations. In physics, we see this not at the moment at the level of discovering new laws, because this has been going on for centuries, and they did a pretty good job. But at the level of contributing to computational physics, so at the level of making predictions, computational predictions, much faster for bigger systems. For example, at Inductiva, we try to do these kind of things. Like, suppose you want to simulate fluid dynamics. You want to put a car inside a wind tunnel and predict what is the pressure points in the surface of the car, or predict the drag coefficient. If you do this by fluid dynamic simulation, it can take you like half an hour or more of compute time. But if you do a big enough data set of these simulations, you can train like a graph neural network to predict this directly in one inference step, which will be of the order of 50 milliseconds. So you will have a trade-off of accuracy versus speed of inference, but this allows you to explore a much bigger space of possibilities. And the same thing I think Joel can share with drug design is literally like that, right? You can try to predict, how a drug interacts with a protein, whether it binds or not, and do this much faster for a much larger number of drug candidates, right?
Well, yeah. Yes. So actually, just a clear statement. So I don't think that it is a silver bullet. I don't think that AI or machine learning is not a silver bullet. So I don't think that it will be able to help us to solve any or every kind of problem or any kind of complex problems. But I think that if properly used, I think that it could help us with a lot of challenges and problems that have been traditionally very hard to be solved by computers and also very hard to be solved by humans. And I think that as I see it, the major contribution of deep learning, it was actually, as you said, it was this latent space, or the representation help us to learn the best representations to identify these patterns. And I think that it is doing that really very well for a lot of problems that are of interest. Actually, I was prepared more or less to talk about AlphaFold, because in the field where I work, the computational biology and bioinformatics, one of the most difficult problems, one of the most challenging problems that have been hardly computational biology, especially the ones from structural biology, it was actually to find, to determine what is the structure of proteins given its sequence of amino acids. This should be a straightforward solution, mainly because it is happening in our cells all the time, and for somehow the chain of amino acids finds this natural structure. But this has been a really hard challenge for scientists, for researchers in this topic for the last, 50 years or more. And actually, I heard that it was promised that this would deliver several, or at least one Nobel Prize for the person that was able to solve this, but I think that someone earned the Nobel Prize in this field and was not able to solve the problem, so it's really hard problem. And 3 years ago, DeepMind and AlphaFold, that, well, actually it is not able to solve the problem, but in itself, because it does not explain, at least as I understand it, how the folding works, how this process works, but it is able, for given sequence of amino acids, to determine the structure of the protein, and is actually now accessible to all the community and to all the researchers that are working on the topic, and in my lab we use it a lot. And I was really interested to hear more from you because you were working there.
Yeah, maybe in the later question I can share some details of how we started it.
Because knowing the structure of the protein, given the sequence, is really, really very important for the developing novel therapies, for determining the role, the structure, the function of the protein. So yeah, so I'm really interested in hearing more from you. Not sure if I answered actually the question.
No, but it was a good compliment. But Cláudia, do you have something to complement here? So what do you have to say about machine learning being this new scientific paradigm?
Yeah, so I'd like to stress something that Hugo said, because when we, this was this very powerful moment when we had a lot of different data structures, categorical, continuous, kilometers, meters, angles, whatever. You had anything out there, and you could translate it into a shamelessly simple Euclidean space, right? Where you add things, right? You take a king, you subtract a woman, or you subtract men, you add woman, you get a queen. So this is like this simple additive structure, Euclidean structure. Okay, so I should really emphasize that the power of this is amazing. And so, but this, in perspective of my group as a researcher and also in Neuraspace, this doesn't take the place for human decision making. So in the end, all of these are tools, and we want them to be as powerful as possible, so that in the end, people can take the right decisions. Okay, so, and then, of course, the scientific method is not shaken by the deep learning revolution. It's nothing of the, let's say, traditional or the basis of what it is to decide and to know how to extract knowledge, okay, and ultimately how to change the course of actions out there. We can automate some things, but in the end, I think it's very important that it is clear that all of this is very much a support to human decision making and responsible decision making. And so, and especially if we talk about what Neuraspace does, which is space safety. So in the end, there should be a very well-informed human being taking excellent decisions and having a system with all the power of joining all the power of machine learning and physics and astrophysics and space weather and everything in order for that person to do the best possible decision and protect us all in Earth. So I think that there is, like I said in the beginning, this is an extraordinary, powerful instrument. It's a very nice, and I think more than having, I have like a chatty model that talks to me when I'm bored. It's good to have these powerful new devices, like I don't know, those electronic microscopes or something. But now it's giving us the relevant information and predicting the relevant things about the future in order for me to make the more informed decision, what is best for humans. So regarding this, I think that in terms of the structure, the decision making, everything is the same. It's always on humans, but all our tools are here, and Inês also works in explainable AI, and so she can also talk more about this, but I think that the goal is always to make humans more capable of taking the best decision possible.
Yeah, it's true, and that's actually my next question, and Inês, maybe you can take on this. So as we consider the increasing integration of AI into this very different scientific research and industry as well, Particularly in the healthcare context, it is obvious that responsible AI and ethical considerations become crucial. So, do you want to share something here?
Yes, I think machine learning, taking a little bit of the previous question, I think machine learning may rise as a new area, completely separated from AI. But I think there is, in terms of ethics and privacy and security and all these, bias and all these things, and I quite agree with Cláudia, with everything that she said, because I think all of these models are very complementary. You cannot talk about only people. I think, this is my own opinion, and you take it as you like. I think people are very obsessed about deep learning today. And deep learning does not solve all the problems. It won't solve all the problems, but this is my own opinion, and it's because I work with other things, and I see that deep learning does not solve some problems that I want to solve, so that's why I take that. But people nowadays think that deep learning is the solution for everything. So if you go to the conferences and to the papers and everything, you see only, actually I am saturated of seeing papers about deep learning. I change a bit here and a bit there, and backbone and architecture and blah, 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 and then it makes a new paper. And this is quite, but anyway, answering your question, I think the way we use technology in general, be it machine learning or any other kind of thing, needs to be, people need to use these things with care. And I see some words in machine learning that are very much biased. And I can give you some examples. Like, for example, skin cancer. Most of the data sets about skin cancer that study skin cancer are biased for white skin. And this is something that should not happen. Also, there are some, if you want to use deep learning and you need to train a model that is very heavy, you need to have machines and very, high power GPUs and so on. But some institutions or some people or some countries don't have the money to do that, right? To have this kind of equipment. And in that case, these people, there is a gap, because it forms a gap between who can do the things and who cannot do things. So I think people need to think about this stuff. And in healthcare, there are several different problems that can appear, like data privacy, anonymization that's not exactly anonymization, because you can never anonymize data properly, because there are some groups of people that, the ones that you want to study, that are very easy to identify, right? Because when you do research in healthcare, some of the problems happen to a very small group of people, because they are rare diseases or some things that you want to study. So this is very easy to, it's very easy to identify the groups. So I don't know exactly. There is a European movement for, there is the regular data protection regulation or whatever it is called. That is, and also there are some movements in Europe for the use of AI in some areas, including healthcare. Actually, I was in two forums where people were discussing about ethics in health and actually life sciences, and another one that was only about breast cancer, and everyone is very much worried about these questions. And at the moment, I don't think that there is an answer. I think the answer is you need people that use the technology and use them well. That's the point. So I don't know if I answered the question.
Yeah, no, it was really, and personally, I agree. Actually, I agree with everything that you said, basically. I don't know if some of you want to comment on this topic as well.
I want, because I have a collaboration with someone that during COVID, people were trying to measure oxygen levels from fingers, but people with a darker skin they cannot get measured. So, this is like amazing how this bias comes to be. Like, it's amazing because those devices are everywhere. Anyone who has ever went to a hospital knows that this is how they do it. And so I would just like to stress that this is an amazing thing that it's in front of us and nobody knows,
Yes.
right? So in terms of biases and fairness, that people sometimes look as like, oh, we also have to address this, right? It's like, oh, but then it gets to be really important. And this brings us to look at machine learning. I'm really saying machine learning because in machine learning models, we train for the expected value, okay? This is what we do. And this might not be the right thing to do when we are looking at applying this to overall world and with impactful consequences. So this is something that I think that the other biases, for example, having the dynamics of physical systems, for example, or the knowledge from some ontologies that we know that are true, right? And we can apply to the system and that can expand this instead of us minimizing the risk and so minimizing the expected error or the error in expected value. We should take into account the full distribution, right, of the error. So this is really interesting.
Maybe I
Yeah,
can
go.
compliment. So actually, I think that the main points were already presented. I don't think that I have that much to add. But I think that just a small comment that it is. I'm not the best person to comment on this because I don't think that I have never put that much thought on it. But as I see it, I think that the bias already is previous to these problems. The bias is already on the society, so I think that's the asymmetry.
Yeah.
And I think that, or at least as I think it is that we can use these new tools, and I think, and we can use them to develop or I think that we can use these tools in a way that could address these inherent problems from the society. For instance, one of the problems is the number of neglected diseases. So it is a huge number of diseases that affect only a small portion of the population. Well, it is not a small portion, but is a small percentage of the population, and it simply does not work for the pharma industry to develop new drugs. And eventually we can use artificial intelligence and we can use deep learning to help in an easier way to develop drugs for these diseases and for these new drugs. So, and I think that this principle could extend to other areas of research.
Yeah, I think I have here a question that bridges very well with this topic. Maybe for you, Hugo, because very recently we, Deep Learning Sessions, did a collaboration with Inductiva, and you shared with us and with the public in general a data set. So I just want to hear from you, why does it make sense to share the data, share code? So what is your opinion on this transparent way to create AI systems?
So thanks for the question, and thanks also for helping organizing that event, and that is really interesting and it involved the community. So my take on that is like, from a business perspective, for a startup, the biggest threat is actually being irrelevant. You are not doing anything useful for anyone. And the second one is maybe you are actually doing something useful, but nobody knows about it, so it's lacking visibility. In both cases, being open is actually, contributing to you getting feedback to see whether you are doing something useful and contributing to visibility, which helps for credibility, it helps for attracting talent, it helps for bringing attention to the areas you think you should grow. So that project is an example of that, right? We shared like a fluid dynamics data set and illustrated a little bit on how you can train machine learning models to predict predict basically fluid dynamics, right? How this evolves through time. We don't see this as as a threat at all to our business model, because this is educational, it's for research purposes, and if this was a business critical, we could generate much bigger data sets, right? But I see this as an instrument to actually differentiate yourself from players that are much more close, and we see this these days with the large language models that now are so fashionable. Players like Hugging Face and others that are doing a lot more open source, they are actually getting a lot more traction than people that are trying to keep things close. So that's our take on this.
I don't know, some of you want to complement this?
No? Okay. So,
I want to talk about open data.
go ahead.
I have a, sorry. I have a painful experience with acquiring data, especially when I work with the health sector, because it's a mess. And first, if you want to get to anonymize everything, you get nothing in the end, because everything about health is about a person. And so, if you want to study a disease and you want to, so in some cases, it's easier to share data, and it's more, let's say if you're talking about large quantities of simulated data and everything, but I think it's also very critical to find there are other types of data that are very, let's say, sensitive, and for example, healthcare, but also in the space domain, because the players, they are, of course, very much concerned about their secrets, about exact positions of satellites, because, I mean, it's actually a political issue in some cases, not all, but in some cases. So it's a very hard trade-off to run, right? I think that the way forward is to have very good models that can model the distribution in such a good way that you could create very likely data sets, likely in the sense of likelihood, really. So, because in some areas in physics, it's very much okay that you share, but in other areas, it's very, very complex. For example, in space, ESA has made available a few data sets, but then if you try to work with them, it's so hard because you have nothing there, no important information like the ones that we see in healthcare that are public. Okay, so it's small data sets, not as much with very masked information, and it's very poor, and it doesn't replicate the true problem. So researchers will be going after some other problem that is not a real problem. So I think that this data situation, the data problem that we have right now, should be addressed. And I had a strong mental note for this question, because if we remember how all these things started, it started with ImageNet. Okay? The deep learning revolution started with some guys making this huge data set available, ImageNet. Okay, so if we see how the impact that all that moment created, also with scikit-learn and all those frameworks that came after ImageNet coming, and then TensorFlow, and then all the other frameworks. So this is the first step, data availability. If it is, I don't know, learned by a very good model that can then reproduce other models or whatever, but I think that this is a very, very important topic.
So basically, I think we are here talking about AI4Science for everyone, this data sharing situation. So my question is, how can we make AI more accessible to people that already work in a certain scientific area, or even to the broader public? So how, I think at the end of the day, my question is how can we improve AI literacy so that everyone can use this as a tool? Inês, I think you can start.
I had a discussion about this with someone some months ago, actually. Actually, a friend of mine wrote a paper about that. About how to, actually it was not how to make AI accessible to everyone, but how to explain AI to someone that does not understand anything about the techniques of the things and so on. I think the model she used was a bit complicated. At least, I mean, I found that to the general people it was a bit complicated, but it was a trial, right? So we should praise it. But I think the main point is, whenever I talk about that everywhere I talk about education. I think people need to be educated about these things in the basic school, elementary or whatever. They need to be taught about these things, and they need to understand what it is. I mean, in very, very simple words. And even in the areas where people do not, people want to use AI, but they don't know exactly what it is, like in the health area. The students that, come to the undergraduate programs, they should have one discipline where they should, someone should teach about these things. Teach how to use the technology, why the technology is good, what are the dangers, what are the threats, and what are the strengths and all these things. Because otherwise, we still have some people, for example, I am involved in a master program that is in medical informatics. And still we receive some students that have some difficulties with the keyboard, right? So this is not AI yet, right? So this is not AI yet. So this is something that we need to solve. That is make the people literate about these things. And so I think everything starts with education. Education since child, because this is going to take over. I mean, AI is something that is going to take over our lives. Actually, everything that we use nowadays has some piece of AI, right? Some algorithm. I'm not talking about machine learning or whatever, but has some algorithm. And if people do not understand how to use those things, it can be dangerous. So, education. That's my answer. I don't know if I
Yeah, no, I'm just thinking because you mentioned it's taking over, but it's already happening. So
it's already
happening. So how can we? I know that education is always a good solution. Starting from as a child learning these concepts, it's easier, of course. But how can we tackle these right now? I mean, sharing the knowledge and making the average human, I know this is wrong to put it in this way, how can we tackle this problem now and make adults understand what is happening? I don't know if some of you want to comment on this one.
Well, I can say something quickly. I don't think for the overall population will be feasible to educate everyone about AI, right? Because there's a lot of deep knowledge you need to build on, like from math, from programming, from statistics, and so on. So the majority of people, I think, they will interact with AI as users, as any other kind of technology, right? Everybody interacts with cars, but very few people design engines for cars, right? In terms of people that have access to more high qualified education, right? They go to universities and they go to science or engineering programs. I think there will be more specialization on the courses that are available right now. Maybe you study data science and you will learn machine learning for language, for speech, for vision, and so on. And I think we'll start seeing, and with the top universities are already doing that, is you'll see, AI for biology, AI for physics, AI for chemistry, and this will be included in the program of those graduates, right? So this
Maybe I can also share my individual experience with that. So in the field that I work, there are actually two communities: the developers or the contributors and the users. So I work in biological computational biology, and most of the tools, the algorithms, and the code and the work that we do, they are mostly to be used by physicians, not so much, but for also mostly for biologists and researchers in other fields. And this has been happening forever in the field. So the idea it is to educate them to be good users, and this also starts, I agree, with education, and I think that all the programs from all the biological courses now have bioinformatics and have computer science in their curriculum, and also starts with being able for us computer scientists to be able to put or to package the work that we do and the algorithms and the models in a way that could be user friendly, could be used without not all the bolts.
Without the API, without the API talk.
Amazing. I think we can talk a little bit about retaining talent. I know this is a very difficult topic. But to start, my question is there a way, or what can we do to bring people from AI to AI4Science, or machine learning, or people from science to AI4Science? What can we do to retain this talent and bring together these two very different communities, let's say?
I can say something big. I think that I think everybody can stay in their places but work together. So astrophysicists can continue to be astrophysicists, computer scientists, scientists, but they should find a nice, cozy place to talk and understand and listen to each other and try to work out problems together. And this just means learning another language, right? It's really hard when we go to the people in orbital dynamics and we try to understand their things that they do for centuries, right? And it has worked so far, right? So it shouldn't be so, and try to translate that to our own and try to explain them. I think that the multidisciplinarity here is very important, and this I also found in my work with health, because we will not be doctors, never, right? So I won't, but so it's very important to have this, just to bring people together that are from different areas. Of course, if we are computer scientists, a researcher in computer science, maybe we are more interested in developing new algorithms, new models, but there is the catch is to take one of those people and say, oh, look, this application here. Let's do this, but now with a second order differential equation. What about that? And then the computer scientist like, oh, no.
Yeah, I see that happen.
Yeah, but I think it's there are people for everything. It's nice that there are people that only do the type of very, very narrow work, but it's also nice to see people that can talk and communicate. How to retain those people? Yeah, well, I'm in two worlds, right? So in academia, it's very hard because we don't pay much. So, but I think that the fact that people are more and more interested in doing things that are important, and this is essential for fulfilling a good life, right? And so what we are doing here in all of these topics is very important, and more than I don't know, having this car or the other. Maybe if you feel that every day of your working life you have done something that is really important, maybe having this stress is something that.
So just complementing, and if I understood well your question, it was trying to address the issues of attracting people or researchers to AI, and that from where I see it, there's no difficulty in attracting anyone to AI. So everyone is interested in AI from all fields or almost all fields. The challenge, at least in the university, is retaining people in AI and being able to educate and motivate people for keeping working in the art part of the problem, not just on the AI. And that is actually a big challenge, at least in the university, because we don't pay much.
Yeah, go.
I can add something because we really are a startup on AI4Science and engineering, and we need to hire people. So for me, it's really clear that people with scientific backgrounds, physics, mathematics, perhaps biology, they, at least in Portugal, they are available and they really want to join our company and get applications from the best people, and they really want to learn more machine learning. So from that point of view, it's there's a lot of interest. From the other stream, like having people from AI to go to AI from science, there's a lot more competition because there's NLP, there's recommender systems, there's search, and so on. And you need to be passionate about these fundamental sciences. So we hire people that care about, they want to learn more math or more physics and so on, and those we can attract. But if they just care about AI and computer science in general, there's a lot more competition.
Yeah, good point. What about in Portugal? I mean, AI4Science in Portugal. I know this is a very difficult topic, but can you maybe comment on the position Portugal has in the areas of AI4Science?
Maybe because I will go and answer that one because it really follows from what I said. So in Portugal, we actually have, I think, a big opportunity here. Why? Because of what I just said before. There's a problem in Portugal, which is there is no very good scientific career in academia, right? There's not many positions, not well paid, it's slow moving, it's bureaucratic, and so on, and it's cannot address all the people that are trained in physics or mathematics cannot become professors, right? So then they have the choice to go to industry. But typically when they go to industry, they will have to requalify in doing some IT and programming and so on, but typically or traditionally it was in fields that they don't actually care about, like banking or insurance or whatever, or e-commerce. So it's not really rewarding for them. So for us, Inductiva, when we get to tell them, yeah, you're going to work in industry, but you're going to still do physics and biology and chemistry. So it's like, it's wonderful. So I think Portugal is actually in a good position in that scenario, in which we have perhaps a surplus of high qualified people in scientific domains that are not getting enough of opportunities in industry. So
Yeah,
I'm confident.
it's that people that come from those areas, but also people, like I said, that are motivated to do a good thing. And I know, for example, in Neuraspace, although I'm not an employee, but I know that people have this feeling about doing something important. And this is really something that you feel, and you are doing this, and you are using these tools that are so amazing, like wizardry, right? And then you are really doing something that will have a high impact in the world. So I think that this is very, very important to retain those people. But about Portugal and the situation, well, I think nowadays it's more or less we can be not we professors, but everyone else can be remote.
Yeah.
So and lots of people from other areas and other countries and other companies come to Portugal to work from here, like the nomads, digital nomads and people like that. So I think Portugal is in the best situation possible. Older colleagues of mine, they talk about those days where they had to go to a conference very far away and bring suitcases full of books and proceedings of whatnot in paper, right? We don't have that now, right? So we can access whatever it is.
Okay. I think we are reaching the end of our session, so I have one question, and I would like to go to, so basically what you could answer. So we have been talking about some serious topics. I think now we can go a bit more science fiction, just for the fun of it. No, but I would like to know your perspective on AI4Science in the future. Now it's on you to choose if you want to go science fiction or not. But here's my question. So looking to the future, how do you envision a future where AI4Science has reached advanced levels and, of course, in some cases, become automated? So what potential benefits, challenges, and ethical considerations can you anticipate in this future scenario? And how can AI and human researchers collaborate synergetically in this evolving scientific ecosystem? And of course, we want to maximize AI potential while preserving creativity, intuition, and critical thinking that human scientists still bring to the table.
Oh my God.
There is a lot in one question.
Just go wild.
I make notes.
Go wild.
Well,
And then we write a book all together.
maybe I can start.
Yeah.
So actually, I think that maybe some of you in the audience share this feeling that a lot of things that I dreamed or that I thought as a kid are a reality now. So they are happening and they are no longer science fiction. So and I'm thinking of electric cars. I'm thinking of self-driving cars. Well, not still a reality, but you know. But I'm also thinking in solar panels everywhere, and a lot of other transformative technologies that are actually already everywhere. And of course, computers. So the computers, it was really amazing. Since my first computer, ZX Spectrum, until actually now, it has been really, really amazing. So I think that we can, hallucinate a little bit, and we can take a little bit from the science fiction books, and maybe we can think of artificial intelligence assistants that could work very well for us. I think that it is something that it will happen, I believe. The self-driving cars that eventually they will drive by themselves, but a lot of other technologies that very easily can be preserved. They can be everywhere. And I remember, and just I'm really, I was in elementary school, and I remember this because I asked my teacher if she thought that cars could ever be driven by themselves. And she said that ever. Ever. And yeah, I accepted the response. Maybe I shouldn't, but I accepted. And I'm not so sure now. Well, so I think that.
But do you have some concerns, maybe on the ethical side of the things, now being a bit realistic?
Yes. So I'm not the best person to discuss them because I don't put that much effort. So I put more effort on the potentialities and not so much on the problems. But I think that as every other technology, it has a lot of possible issues. But I think I'm very optimistic. Okay, I'm very optimistic, and I think that we as society, at least so far, we have been able to address the challenges that come by. Yeah, we started with a fire that's lots of burns, not very good, and we went all the way through until. So I'm very optimistic.
Good, that's good.
Yeah,
that's good.
Yeah. I'm not really concerned about 2055 and robots taking over. This is totally not my concern, because I think that there are some dark sides of all this thing that has been happening, but they are happening now. Like, for example, to get the huge data sets, you need a lot of human labeling that sometimes is done under very bad condition. So you sometimes some training of some models, we know they are so huge that they take a lot of energy from our planet. So I think that the major concerns that we can address, they already exist now. About the future, it's like your elementary professor, teacher. I mean, it's so wild to predict what will happen in a few years. I think it's, for me personally, I feel happy enough in doing my best job for next year, next semester, okay? And at the same time thinking about what is happening now. What are we, so how can we improve? And Inês pointed out that sometimes, so the way we are burning energy to run models, this is also excluding people from training those models. We all been through that when we try to train models in our computer centers and they don't. But so this is another aspect where we can ask our friends scientists and our friends from applications and help us and build networks, for example, that can encode more knowledge inside themselves, and so they need to be simpler, okay? Or try to collect data that is cleaner. Microsoft Research published a few days ago a paper called "Textbooks is All We Need." It's really a nice paper because they trained a language model that is much, much smaller than the usual models, just because the data set was from textbook. And this is such a nice, interesting thing, right? So if we just keep the chatter from the internet out of the models, they get better with smaller impact on the environment. So I think that this is, because it's wild to say, oh, Terminator is coming and then he will have 3 arms and whatever. So I like it. I think it's more, if our horizon is more realistic. Good. Like your answer.
Okay, so first what I hope it will happen, right? So we have this list of big problems that humanity has not solved, like climate change, clean energy, a lot of diseases that affect billions of people. And our belief, actually it's kind of our mission at our company, is actually to enable some of the solutions for these problems with a blend of simulation and AI. So if we think a few years ahead and all goes right, we could live in a world where we have clean energy and we are not putting more CO2 in the atmosphere. We could live in a world where most of the diseases that affect a lot of people are under control. And you could be potentially in the world, now not necessarily on thinking on AI4Science, but you could be in a world in which a lot of the boring things are more automated, right? Like it could almost be like a human right to have access, let's say, to free transportation or potentially free housing, right? If you have robots that can renovate houses really easily, or if you have self-driving cars that drive everywhere and you have clean energy to feed them. So potentially you could be in a world where it's sustainable and the basic infrastructure that keeps people safe and you have access to food, transportation, accommodation is kind of sort of granted, right? And that would possibly or could potentially happen with the help of AI. Now, what I fear is that for any kind of advanced technology, great power comes with great responsibility, right? And the same, even though the barrier to entry to solve these hard problems in a positive way is decreasing, so that's good, the barrier to mess up is also decreasing, right? So there's, talking about ethics, there's research on showing, you can create machine learning models to help find, drugs to cure disease, but you can use the same model to ask for molecules that are the most toxic possible for some cells or so. So my fear is that potentially bad actors, and you cannot control everyone, could have malicious intentions. In terms of automating away too much, in terms of having what is called rogue AI, right? Like AI gone wrong. my concern is similar. So you can progressively devise or construct systems that are more empowered with agency, right? They can take actions on themselves. They can, make bank transactions, book things, or move objects around, and so on. And there's potentially a lot of good uses for this. But if you give more and more agency to more and more powerful systems, it can also go potentially wrong, right? So my concern is that most of the players in the machine learning community and most of developed countries and so on, they are trying to maximize the good outcome. I'm not too afraid that they are trying to mess up. But you enter a game theoretical scenario in which, it's enough that some bad players, even if it's a small proportion, could have a big negative impact. So that's a bit of a concern, and I think that's why the community is starting to talk about this before it's a bigger risk. But I'm still hopeful that we can drive most of the human effort and ambition towards the good outcomes. So let's try to do it.
Optimistic in the end. That's good.
Very good, very good.
I agree with my colleagues. I think I share their opinions. I think there is a threat for some of the AI systems, which is people become lazy. Become lazy in a sense, not become lazy of not doing anything, but becoming lazy of criticizing things. So they trust the system, and they believe that the system will always do something good, and when something goes wrong, they don't criticize. So this is something that I actually something related with Hugo was talking about. And related to the future, I think, I don't know if you know cartoon, not a cartoon, vamos desenhar? Comics. Yes, the comics, the Jetsons. So this is I think Jetsons, have you heard about that? No.
No.
You that are very young, I think you never heard about it. But anyway, the Jetsons is a very good comics where everything is automated at home and the systems are all intelligent. You have cars that go all the way synchronized and so on, blah blah blah. And that's Joel was saying, he had some dreams. My dream was to see a world like that, and I think we are going to get there. With some problems along the way, but it's not my generation. I think it's not my children's generation. But I think we are going to get there at some point. So although, as Cláudia said, it's difficult to predict. But anyway, I am optimist like Joel.
Yeah, can I add something? Because I think that this question about dangers of AI, and it's a very old one, right? It started with McCarthy in the 50s. Already there, they were asking this. And it's more or less, what I feel it's beyond the scope of my abilities to do that. I think we would, again, a multidisciplinary team with more people leading the sociology point of view, the legal point of view, because, or the anthropological point of view, and then us in our side doing this, because then I feel that this is something that we really have to start doing, gathering these teams. Or else we will continue this in this type of conversation. Since McCarthy, I think this is so important to look back to those conversations, because they already were discussing this, and now it's the time. It's coming, right? This is happening, and so we should start doing this. Well, maybe not us, but some kind of authority should start doing this. Joining people from relevant fields, and because what I feel when I see all the papers that were written from those times, all the discussions that were held, is that we could, at some point, we cannot go any further, right? We don't, and at some point it was not important because it was just some research theoretical question. There is this problem of the train that had two branches, right? If it goes in front, it would kill the a child in the line. If it went to the other side, the driver would be killed, right? And now we have self-driving cars. So this question is now very much present. So it's no longer something that we people involved in this matter should discuss alone. So this is my point of view.
That's a good point. That's a good point. Thank you. I have to say that I loved your ideas. A book might come from all of this. Let's see. We can start with the questions, so go ahead.
I have a question for Inês. So, why is it so important to do the exploratory data analysis? So I want to know why is it so important in a way of...
I think we should do that.
You have to speak louder also.
Yeah.
Yeah.
So I want to know why it's important to do the exploratory data analysis in healthcare. You say that it's important, so why it's important?
Well, why is it important to analyze data, healthcare data? Because we want to analyze the data in order to find models that can find patterns for some kind of disease or some kind of distinguish, for example, a cancer that is malignant from something that's benign. So that's why we use the data and we want to analyze the data. But I don't know if this was a question. You're saying, you were talking about exploratory data, right? Data analysis. Exploratory data analysis is the basis for building the models. So if you manage to analyze the data and find that some percentage of cases have some, I don't know, I mean, suppose that some cardiac pathology people have a problem with their kidney, for example. You can separate that group of people, and then that's why you need to do this kind of analysis for the data. I don't know if I answered your question or not. So you want to characterize the patients. That's the point.
Can I jump in? Because I love EDA, exploratory data analysis, and it's the exact first point of your work. Okay. So first of all, you have to know that your data can answer your question. This is the basic thing.
Yep.
Okay. So if your data does not have the variable that you need to predict, this will be an impossible quest. No model will give you that. Or if your data has the variable, but the variable is a constant number, you will not be able to do anything with that model, with any model in the face of the earth. Okay. So exploratory data analysis is an area that people in machine learning always I don't give that much attention, but it's the basic beginning of everything. It's where everything starts. Okay, so this is, and this is very nice that Inês also mentioned this, and I made also a mental note on that, because it's really a fun moment. It is. I like doing that. I like doing it again because you are like you put your Sherlock Holmes hat, you know, and you start like asking questions. What if? Where is this thing? And you go and search, right? You do a plot. You do. Oh, I can't believe it. Let's see some other view on this data set. Okay, so this is very interesting. It's a moment of play. If you have a deadline, it's not that fun, but in general, yeah. So imagine that you are having like a big data set of orbits, but you have XYZ positions in space. First thing you'd like to do is visualize. You plot the 3D of the orbit, and it looks amazing, right? It's really nice. It's not like a big table of numbers anymore. It's something that you can touch, and this is very nice.
Next question. Yeah.
So thank you for the really interesting talk. My first question was about something that relates to what Cláudia said at the end about this multidisciplinarity thing and talking with people from other fields. I have a concrete case of something about that. Is that a friend of mine, she was working with complex networks and in the political domain, and she was creating visualization models and description models of political party affiliations. And it was really interesting that when she reached some conclusions about how the movements of political parties in Brazil were working and things like that, and when she talked with people from social sciences and political sciences, they said, yeah, we've been talking about exactly this thing 2 years ago. And so it's something that there was a missing piece there, like talking with people from other fields, from humanities that works with this same object and same case. They reached some other conclusion that I took all those years to get using machine learning and computer models. So I have a question for all of you. So how do you deal with this during your researches? And if you do, and how do you talk with people from other fields?
I would be happy to mention something on interdisciplinary teams that I didn't have the opportunity before, and maybe it links to your curiosity about AlphaFold. So when I was at DeepMind I joined in 2015 and we started AlphaFold. Actually, the funny fact, it was a hackathon project that myself and 2 people started playing with this folded game in which there's a graphical interface to fold proteins. And we wrote some small programs with neural networks and search to play that game automatically. And then it became a real project where we worked on this full time, and some people that worked on AlphaGo before joined, and it became a real project. But now the curious thing about interdisciplinarity is that we were all machine learning researchers in the engineers, and the only input we had from people that know biology was a professor of bioinformatics in UCL, and then that came for 2 hours every 2 weeks. And that was all. So it was very important because he allowed us to avoid some silly mistakes, and so he guided us to, do the right thing. But it's important to know that then the bottleneck of execution really shifted to machine learning. Once we formulated the problem in a computational way, we know what the output is and the output is, we have these access to these databases, we know algorithms, and now it becomes about modeling, trying a lot of ideas, a lot of experimentation, and measuring whether this is making progress. And in that part, we didn't need any help of biologists. So you need some input from domain experts, but in the end, the bottleneck of execution, like 95 or 98% of the effort of the team was machine learning engineer. So perhaps not many people know that it was that unbalanced in AlphaFold. It was really machine learning.
If I can say something, I don't know if I understood correctly your question, but for example, when I was working with breast cancer, before building any model, machine learning model, what we did was a bibliography review in order to find out what was the performance of the best experts in that area, without using any algorithm, just their minds, right? And this needs to be done, because otherwise you produce things that were created 2 or 3 years ago by the experts in the area. So you need to know if the system is actually, this is a good result, actually, to me, from my point of view. Finding an algorithm that can replicate what someone did 2 or 3 years ago is interesting, because you can prove that your program can do as good as an expert, right? But of course, you need to compare your algorithm and your program with the results of the experts that are working in the area. Otherwise, it's not interdisciplinary at all, in my opinion, anyway, so, yeah.
I can also say something if I may. So in my lab, I'm a computer scientist, but we have, some of us have background in biochemistry, others in biomedical engineering, data science, and bioinformatics. So we have at least these 4 profiles. And I collaborate with people from the pharmacy, department, and for chemistry and biology, and even from biology I can. So I collaborate with people from different backgrounds, from genetics to proteomics, and so I know what it is to have this interdisciplinary or multidisciplinary works, and the challenge that may appear from communicating, and from so sharing ideas or to discussing ideas when your language is different. So yeah, so I can relate to that. But I also I completely understand Hugo that sometimes you just need to be able to model the problem and to have the time and of your own to be able to implement it and to solve it and so there are these two different parts of the interaction. Yeah.
Also, I have let's say a weird point of view because I live with myself and I'm interdisciplinary by nature. I have a degree in literature and also in engineering. I did a master in linguistics and in, well, whatever I did to be a professor in computer science. So I can live with myself, but sometimes I have shut down shut up one of my parts and then put the other to work. So because there is this interface, like everyone said, so there is this interface point which is very energy consuming because you are like translating all the time. You're trying to model something, so you're trying to translating from a orbital dynamics perspective to a model, like a mathematical model thing all the time, and it's not the same thing. The words sometimes are too close. That's a problem. And then, so what you have to do is to have these very intense moments that you're like communicating, absorbing the model that you want to, what are the goals, like the inputs and outputs that you want to do, the guarantees that you must provide. What is the priority list? Because it's very important to have a ranking of things, of wishes that the people that you're working with have, because you can at least say, oh, well, the first 5 of them, they are not possible. But there are theoretical limits in information theory that say that you cannot have these 5 things in top. But it's important for you to have like these contact points that are very difficult to manage. And then you kind of go and get your work done. Okay, so this is, it's really hard, those moments where we are together, but they are really extremely important. Maybe if that professor was not going there twice, just to validate, you are
really
still going on the
that
right
phase
way.
of translation, right? It's like translating a problem that comes from one domain to another where you will operate. So at that point of translation is really important to understand the domain specific. But once you manage to some extent to translate, now the bottleneck of execution shifted. And then if you are modeling with machine learning, then you need machine learning.
Yeah. So this is really a very, it's not that not everyone is apt for this type of interfacing. Okay, there are some people that can only work, but this is okay. We should have teams with all types of. This is very much okay, and it's very enriching as an experience, but it's also very energy consuming. I think everyone shares this because it's really tiresome. Okay.
Yeah, maybe, yeah.
First, I want to thank you for the great talk. My question is about, like, today you have a huge amount of data. Everything and everyone can be a data, and my question is, how in the near future, like in the future like 10 or 5 years, can we guarantee like a machine learning or a AI model don't will hurt the freedom of information and a person's privacy? So how do you think we can guarantee like this huge amount of data will not hurt the individual privacy of each person?
I can start with a very radical view. I have an extremely radical view on this, which is I think that everyone should own their own data, okay? And you should have, like, somebody needs to do some cancer research, needs to consult your data. There is this very interesting area that I'm also working on called federated learning. What you do is each one has its own data. You just ask permission. Can I use for this, this, and this? And you allow or not, okay? This is my radical view on data sharing is no data sharing in the sense of personal data, not the one that we could generate by some other generative model that could be used as research. But for in terms of data privacy, this is my very extreme view on sharing, no sharing.
Not sure I can.
I agree. I think that's the way to go. Actually, in the US, in the healthcare area, patients need to sign a letter of consentment if they want to make the data available. If they don't want to, they say no. I don't allow. So I think this is the way to go, because it's I personally think that if there is no protection, companies or insurance companies or whatever, they will do whatever with your data, especially in the healthcare area. I mean, I'm talking about healthcare because it's something that I know more. But yeah, I don't think that we have a way of preventing that to happen. But if you, as Cláudia said, if you put in the hands of the user, I think this is more control. So I am the owner. Someone sees my data if I want to. That's it.
Yeah, there are very interesting initiatives by the EU on data spaces, even for companies, that there is this concept of a data space where you kind of allow other parties to kind of train a bit on your data, but then it's again in more or less on a federated whatnot area. But so this is a problem. I think of that. What was really push that area in the EU was that leakage of data from the Chancellor, from the German Chancellor, because the US got to her data because the servers were in the US and because of the Patriot Act and stuff. But it's good that somebody is pushing this topic ahead. So this is really.
I think that in the EU we are doing the things that are supposed to be right, but meanwhile, in the other part of the world, well, the rules are not exactly the same, and I'm referring to China, where the data is not ours, exactly. And actually, it has been able to supposedly to contribute to advances because the data is all integrated, and eventually they will be able to advance more for instance in the drug discovery, because all of the clinical trials, they are centrally available, and then they can test all the possibilities and use large models or machine learning models to try to use them. And somehow one of the criticisms in the EU is that we are not taking the most from the money that we are spending in all of this in these programs, and maybe some advances should be happening, but they are not happening, and therefore some people are dying. Maybe eventually they didn't have to. I don't want to enter into this discussion, but I think that this is something that we need to think about.
Yeah, so I'm not an expert in privacy, but I would just like to add, first of all, it's like both societal thing and also a personal thing in terms of preferences, right? Like in some societies, people are just much more comfortable in sharing and not having as much privacy as others, are much more sensitive. And also it's about who you share it with and you trust, right? So you are perfectly comfortable to share all the contents of your emails with your loved one and so on with Google because you have enough trust that they will not be hacked and it will not be leaked. you are kind of comfortable to have your health data in some hospitals you went through. Well, maybe you shouldn't trust as much their security systems, but it's kind of in the hands of someone that's supposed to look at your health data, right? You trust your bank to keep a track of your transactions and so on, and you don't want them to be erased. So it's a matter of how much you share with whom and what you trust that is working. The other thing is that there is a trade-off between privacy and just practicality, right? When people, for example, in the open source movement, there's Richard Stallman is like an advocate of open source and so on, and he really cares about these things. But then many aspects of his life will become impractical, right? For example, he will not use a smartphone because he will not have enough privacy guarantees, or he will not use many different operating systems because he doesn't trust, or maybe him or some other person will not fly because this will be registered somewhere and some government has access to this. And for most part of the population, you are willing to give away some part of your privacy just because you want to live your life and operate, right? So I like what Cláudia mentioned regarding federated learning, because it's a machine learning approach in which you can kind of get the best of both worlds, in which you can get, for example, machine learning models that are trained to be personalized to your needs and so on, but your data doesn't need to be centralized in a storage in a central place. Your local device will just compute gradients on your local data and send this, and this will be aggregated in the server without sending the personal data. So I think this is a kind of a way of getting some of best of both worlds, but I think it will be hard to have like total privacy.
Yeah, I mean, it's like areas, right, of your life, right, that it's really, you don't want people, I do some work also with telecommunication companies, and I will not say the name of them. It's shameless, the quantity of information that they have on us. Okay, so it's like shameful, the amount of information they
but
have.
just think of pictures, right? It's not even surveillance cameras. This can be in many locations in even European cities, and so if you walk around, this can be registered. But even ignoring that, just people are taking pictures of their loved ones, and you are behind, right? You are at the beach, they take pictures, and you are behind. So this will appear in, I don't know, Google Photos or other services, and if they have enough, and they have now face recognition capabilities, you could easily be potentially spotted in someone else's picture. But how are you going to prevent this? You cannot forbid people to take pictures of their loved ones at the beach just because someone is behind, right?
Yeah.
So
I think it's good sense, right? Basically, some things, probably the fact that you have some clinical history of a given disease, you don't want to share that with your insurance company, or somebody, or a bank that you are taking a loan, or something that you did in the past that it's your life and stuff like that. But so I think that we can more or less have good sense taking care of. So that's why I believe, like, ask me if I'm available. Like you were saying, like there are people with different options, and all should be respected. It's like the safest thing in terms of people living their lives as they wish is give them the option. So, and yeah, federated learning is really a big thing, and it should be. Yeah, even in space, if you think about different space operators collaborating into having a safer space environment, if they share information, they will never share, of course. So if you have a more or less of a federated learning environment, it will be really amazing. Yeah.
Well, I know there are more questions, but I think we can have those in the coffee break. Many thanks for accepting the invite and being here. This was such a wonderful conversation and discussion. And thank you Neuraspace and IPN for sponsoring and making this event possible. And that's it. Thanks, and let's go have a coffee break. Thanks.
Thank you.